Okay, in this problem, we're to calculate the power that is absorbed or supplied by the network elements. You can see the elements there. Before we begin our calculations, let's review very quickly the passive sign convention. And if we look at the box over there and we have the voltage and current for the box, and they satisfy the passive sign convention, because if you notice, the current enters the plus on the voltage, comes out the negative, and as described in the textbook, that's the passive sign convention. And when the voltage and current satisfy this convention, if we take their product, V times I, that'll be the power absorbed by the box. So now let's keep that in mind and look at our circuit. Let's first start off with element number 1. And if we look at element number 1, if we look, we note that the current is 1.5 amps is entering the plus, coming out the minus, so that does satisfy the passive sign convention. So if we take the product of V and I, we'll get the power absorbed. So for element 1, it's absorbing 9 watts. Now let's look at element 2, down on the bottom of the circuit. And again, we can see the current entering the plus, leaving the minus. So again, that's the passive sign convention. So we now have 9 times 1.5, which is 13.5 watts absorbed. Okay, let's look next at the 12-volt source. And again, if we note, the current IX is flowing down. It's entering the plus and leaving the minus. So again, we're going to get power absorbed because that satisfies the passive sign convention. Okay, so the 12-volt source is absorbing 18 watts. Now, let's look at the dependent source. Okay, and the dependent source is here. And if we notice, first just checking the passive sign convention, this element does not satisfy the passive sign convention because current's entering the minus and coming out the plus. So since it doesn't satisfy the passive sign convention, when we take the product of V and I, that's going to be power supplied. Now if we look and note that IX is equal to 1.5 amps, so that tells us then that 2IX is going to be 3 volts. Okay. So now if we take V and I, since this doesn't satisfy the passive sign convention, we're going to have 3 times 1.5, that's going to be 4.5 watts supplied. Okay, and that leaves us one last element. That's the 24-volt source. And again, if we notice, current's entering the minus, coming out the plus, so it doesn't satisfy the passive sign convention. So when we multiply V and I, we're going to get the power supplied. So we'll have 24 times 1.5, which is 36 watts supplied. Now, as a quick check, if we go in and add up the power supplied, we're going to get 40.5 watts total supplied. And then if we go up and sum up the power absorbed, we're also going to get 40.5 watts absorbed, which verifies Teligens's theorem the power absorbed is equal to the power supplied.